Hi, my name is Brenda Lindgren. I am a graduate student at Morningside University, and I'm here to talk about my research on the effect of explicit math fact instruction in small groups in second grade on the math computation portion of the Iowa assessments. The problem that I was finding was that elementary age students are not becoming proficient in math fact fluency, and it is affecting them later on in middle school and high school on high stakes assessments. According to the NCES in 2009, only 32% of eighth graders received a proficient score on standardized assessments. The gap in the research that I found was that students are not becoming proficient in math fact fluency in elementary school, and it is affecting how they complete higher order thinking skill problems. This means that when students are asked to solve problems that have multiple steps in them, they are spending more time figuring out the math fact problem, the simple addition or subtraction problems, instead of the skill that they are actually being assessed on. So it's not showing a true representation of what they do or do not know, because they could be missing that math fact instruction. And so therefore they're missing those math fact problems in the higher order thinking skill problems that they are really being assessed on. So I did some research to find what could be done to help these students retain math facts in order to move on to the higher order thinking skills. And in my research, I found that Bruner researched the scaffolding of skills. Scaffolding is where it starts at the bottom with a smaller skill. So in this case, the smaller skill would be the math fact instruction, the explicit, the direct math fact instruction. This would happen with a lot of teacher support before then moving on and releasing the students to be able to do the higher order thinking skills. So that concept really helped to design this study, starting at the bottom, teaching that lower skill of math fact fluency before moving on to complex skills. Another study that was done was by Benders and Kraft, and it was on small group instruction. Also in this study, small group instruction was used to find if that scaffolding of skills being done in small group instruction could also help the students retain the math fact fluency skill better. This study found that there were many positive effects on student achievement when instruction was being done in small groups, because the instruction was really individualized for each student in those smaller groups. Also, likability groups could help each other out in those groups. Another study that was done was about the cover, copy, and compare strategy. This strategy was used in this study during the small group instruction in the experimental group. The cover, copy, compare strategy is when the students are assessed first on the math facts with flashcards. So the teacher figures out which flashcards the students already know and which ones that they don't know and they need practice on. So each individual student is assessed, and then they are given a practice set of flashcards. These flashcards have math facts that have the ones that they need to practice with some of the ones that they already know mixed in, just to help retain those facts as well. In these studies, they found that this strategy was very successful because with all of the practice of the flashcards and the repetition, it was able to increase their correct answers because they were given so many opportunities to practice. So this strategy was used in this study in the small group instruction. Touch points was also another strategy used in the small group instruction. This is where the students are taught that each number has a dot on it that corresponds to that number. So the number 5 has 5 dots on it. So, for example, in an addition problem, if you have the problem 5 plus 4, the student was to find the number that was the biggest, so that would be the number 5, and then they would count on the touch points of that next number. So they would start with 5, and then they would touch the 4 points on the number 4 while they were adding. So they would say 5 plus 1, 2, 3, 4. Or they could say 5 plus 6, 7, 8, 9 as they were counting those touch points. So they would find that the answer is 9. So this strategy was used as well during the small group instruction time in the experimental group. The purpose statement of this study was that because students are not becoming proficient in math fact fluency, it's really affecting their scores on the high-stakes assessments. Studies have shown that, and according to the nation's report card, the United States has really gone down in math scores compared to other countries. I also found in my school that our high-stakes assessment scores were staying pretty stagnant and not increasing as well. So this research was conducted to see if explicit math fact fluency instruction in the small groups would help the students to retain those skills and be able to move on to the more complex skills that are on those high stakes assessments and help them succeed on those. So the hypothesis was that the students receiving the math fact instruction in the small groups would score higher on the math computation portion of the Iowa assessment than the students who were just receiving whole group instruction. The independent variable was the math fact instruction in the small groups, and then the dependent variable was the math computation portion of the Iowa assessment, which the students took in both first grade and second grade as a pre-test and a post-test. So the participants in this study were 2 groups of second grade students, and each group had about 20 students with ages varying from 7 to 9. There were varying SES backgrounds, but the majority was mostly Caucasian, and they were separated into 2 classrooms. And in each of these classrooms, there were a couple students in each that had IEPs for math. The materials that were used in this research was the Go Math curriculum for second grade, flashcards, and then also each student was assigned their own individual Chromebook for the whole year as well. The control group procedure was done all in whole group. So they were given 40 to 45 minutes of whole group instruction using the Go Math curriculum. Then at the end, they had about 15 minutes or so of computer time on their Chromebooks, which they were given the opportunity to complete the website Extra Math, which is math fact fluency practice. In the experimental group, all of the students were split into 4 small groups. During small group instruction, they were given in the first 5 to 7 minutes the cover, copy, compare strategy and the touch math strategy. And then the last 10 minutes or so, they were given the curriculum Go Math instruction. While the other students were not at the small groups, they were at math rounds. They had 3 rounds to complete. The first round was technology, where they were also to complete the website Extra Math. Then they had independent practice time, where they completed the minute math worksheets, which were review skills for them. And then they had a math fact round where they practiced flashcards and games that went with addition and subtraction facts. The data analysis was done with an independent samples team test to compare the scores of both groups. The students were given the math computation portion of the Iowa assessment in first grade as a pretest, and then again in second grade as a post-test. And those scores of each group were compared to see if the small group instruction showed that it helped to raise their scores higher than the group who received the whole group instruction. The results of the pretest showed that the groups scored about the same. The control group scored 153.55 on the assessment, and the experimental group scored 154.37. So not that much of a difference. The post-test also showed that the hypothesis was not confirmed because they scored very much the same. The control group scored 188.09, and the experimental group scored 188.42. And you can see these results in the tables as well. This is from the pretest, and this is from the post-test for each group. The limitations and suggestions for future research. The duration of the study was not very long, and also the explicit math fact instruction in the small groups was only about 5 to 7 minutes every day. So for future research, this instruction time could be longer to help them get more practice on that math fact fluency instruction. Both groups were also fairly small, so a bigger sample size could help as well. Also, there were students with IEPs who were pulled out, and they were given more math instruction, so that instruction could be tracked to see if they were given more math fact fluency instruction during that time as well. Also, the small groups were placed randomly, so if the students were put into like ability groups, the instruction could be more individualized as well, and that could help them retain those facts. Also, flashcards were sent home to the experimental group, and they were supposed to complete them as homework once a week. This data could be tracked more to see if they were actually doing these things at home or if they were not. And then the control group was given practice time tests for addition and subtraction every week, and the experimental group was only given them every other week. So this could be tracked as well and be given more practice for the students as well. There were some implications to this study as well. Both whole group and small group were shown to be effective. So this means that really no matter how you teach explicit math fact instruction, it needs to be done so that students do retain those facts and they are able to move on to more complex, high-order thinking skills. This also shows parents that working with students at home on these math facts can really help. This is something that parents can do at home, just as simple as flashcards. So they really need to understand that this instruction really helps them in their future. The last couple slides are my references. Thanks for listening.